Hello students, welcome back. So now we are going to talk about the programming and we are going to talk about the Verilog programming language. So in this video we are going to talk about what is hardware descriptive language, what are the commonly used hardware descriptive languages, what is level of abstraction, how many levels are there. We are going to talk about the structure of a Verilog program and what are the design methodologies used for a digital system design. So let us get started. So first of all, the question that we have in our mind is that what is HDL? HDL stands for Hardware Descriptive Language. HDLs are used to describe the hardware of a digital system. That means the circuit, but not using the schematic diagrams, not by dragging and dropping the circuit elements, but with the help of text-based coding. We are going to design these hardwares at different levels of abstractions. That means by using different coding styles. We will discuss them in detail in our training. We can simulate the hardware and then we can send it for the fabrication. HDL is also helping us in the verification of our design. So whatever we have designed, we can verify using the same HDL using the simulation. We will be discussing them when we come to the coding part. Let us talk about some commonly used HDL. There are two. The first one is Verilog and the second one is VHDL. Let us talk about Verilog. So Verilog is mostly used in the industry. It is very similar to C programming in the syntax and very easy to learn. In this training, we are assuming that you have no background knowledge of this programming and we will be starting from the scratch. This programming language has less number of programming constructs and this makes it ideal for the beginners. Without getting into the complex constructs, you can write very simple codes. So these are the properties of Verilog. Now let us talk about VHDL. VHDL stands for Very High Speed Integrated Circuit, HDL. This is more popular in the academics. The codes are lengthier and they are completely different from the C programming. There are more programming constructs and it provides the facility for high level modeling as well. So both the languages have their own advantages and limitations. We are selecting Verilog keeping in mind that in future you have to go to the industry and you will be mostly working with Verilog. When we talk about the levels of abstraction, in both the languages we have 4 levels of abstraction. The level of abstraction is the complexity by which we want to program our system. The higher levels means less complexity and the lower level means we are going to have high complexity in the design. The first one is algorithmic or the behavioral level. Here we describe the algorithm, the concept which is controlling the design. So if I have to design one full adder, I'll simply say add the number A and B and that's all. So we are describing the behavior of the digital system. I am not talking about how to connect A with B and all these things, nothing. Then comes the second level, which is data flow. In this type of modeling or the programming, we are going to use the Boolean expressions which relates the outputs with inputs. And then we have another lower level which is at the gate level. Here we are going to write the code using logic gates. AND gate, OR gate, XOR gate, whatever gate you have studied. So we will be coding using these gates. And the lowest level is the switch level. Switch means the transistors, the BJT, or in now modern technology, these are CMOS. We are not going to program using the switch level. So in Verilog, we will be focusing only on the first three, that is behavior, data flow, and gate level. Switch level is mainly for the backend, and our focus is mainly on the design aspect. Let us see a typical structure of the Verilog program. We are going to have two main blocks. The first one is called design block or the module. This is going to contain our code that will have all the inputs and outputs, their relation. So this is what we call the design part. Once the design is done, then we go to the testing. Here we are going to mention how these inputs are changing, how many times they are changing, for how long, and for how many test cases I am going to test my circuit. All these things come inside the testing block or the stimulus. We follow certain design methodologies to design a digital system. There are two main approaches. The first one is top-down approach and the second one is bottom-up approach. In the top-down approach, we decide the main logic, then we bisect and divide the whole system into multiple sub-modules. Then we pick each sub-module and try to divide it further into simplest possible circuits. In the bottom-up approach, we do exactly the opposite thing. We select the bottommost, the simplest logic cells, start connecting them, and come to the top and implement the whole system. Let us understand the same with a flow chart. So on the top, I have the top level block. I identify that this block can be implemented using 4 different sub-modules. So we implement them. We have to also identify the relation between these 4. How are they going to be connected to make one top level block? Then inside each sub block, we identify even simpler elements called leaf cells, and then we start working with them and we connect them. Leaf cell of one sub blocks are independent of the leaf cells of the other sub blocks, so they are not going to be mixed. So now let us have a comparison between the type of simulators that are available for coding purpose. We have proprietary simulators which are on the subscription basis, and we have open source simulator which are available for free. In the proprietary, we have ActiveHDL, MPSim, Quartus or also called QSim, and Xilinx simulator. In the open source, we have Cascade, TKGate and Verilog. For our training program, we are going to use Xilinx simulator. It is a subscription based simulator, but the Webpack edition of the same is available for free for lifetime. The Webpack is having more than enough features for a beginner to get started and experience every possible feature of the main simulator. So we will be using the Webpack edition of the Xilinx simulator. So students, now that we have decided that we are going to work with Verilog using the Xilinx simulator, so in the next video, we are going to talk about the Xilinx Vivado design suite, how to install it, how to access it. Keep learning. Thank you.